Jakob is with Align Data Centers, and we've given him the topic, how cloud loads and edge compute are driving the evolution of the data center.
So when I was talking to George last night and about the title of the presentation, he suggested it's the morning, people are excited, there's a lot going on in the world that people are scared about, they want to hear something uplifting. So I changed the title of my presentation to kind of a more uplifting topic. And I'm not just talking about the present choices for presidential candidates. If you watched the debate last night, and I watched the debate last night, although I used a little bit different viewer, this is what I was watching. This is a picture of the global internet during the debate. And very interesting from just the edge compute and cloud and what was happening. If you look at the start of the debates, the content was really on the traditional cable and service providers. Towards the end of the debate, it all quickly shifted over to the content delivery networks, right? People rewinding clips and going after the content. It was kind of an interesting kind of picture of what's happening in the internet. Some stats for you. This is the start of the debate. To the right is the end of the debate. Twitter, one of Trump's favorite, is an interesting data point about, and you can't see it on the bottom of the slide, I apologize for that, the projector cut it off. You had 100 million tweets between the start and the end of the debate last night. And this morning, at the start of this conference, you had as many tweets, or half as many tweets as you did in the 24-hour period prior. So Twitter is alive and well and moving quick. And don't worry, the internet didn't break, and this is hard to see, but the cyber attacks are still going well this morning. So the main cyber attacks are Beijing and a quiet place in Utah, which many of you may know. And you had Brazil. Every conference, I removed the dates of this ubiquitous slide because every conference that I've ever been to shows a slide like this. It's the same one every time. You can kind of get a feel for the past growth that you've had, and everybody tells you you're about to hit the hockey stick. And they tell you it's going to be a function of social media, growth of data centers, growth of voice over IP and video. I decided to use a little bit more plain, simple metric. The internet traffic, 1992, start of the internet, 1 gig. Everybody knows what the thumb drive 1 gig looks like. That mouse is 1 gig, right? If you look at today, where we are today on internet traffic, we're talking about a mouse that's the size of 23 times the diameter of the Earth. A lot of growth. If you talk about zettabytes, how many people have a grasp of how big a zettabyte is? We're going into an age where we're going to start counting traffic and data storage in terms of zettabytes per year. You're talking about a mouse that's 7.5 times the distance between the moon and the Earth, right? So we truly are looking down the hockey stick. And if you look at cloud, the internet, it's really been keeping up. I mean, we have good service, we have good technology, but there really has not been change in the data center, I don't believe, or the level of change that needs to happen. If you look at kind of the economics, which to me really drive the industry, server business has been flat, right? And the reason for that, although you have more servers every year, as we know, the data center server cost goes down every year. It's been a relatively flat business. It's become commoditized. And the reason for that, if you look at just the growth of units and the output and performance, think about back to that slide of the start of the internet, traditional servers, and where we are today, and that kind of massive growth. It's been offset from a technology perspective. But the data center has really not improved at any level of that scale. Today, we're still building data centers that are 4 kW per rack. The industry, a lot of the large cloud players are going to 40 kW per rack, and we're talking about even higher. And I've been in previous conferences, and this kind of started in the banking industry, which was the first ones to get on this density craze of, we're going to high density compute, and then after that kind of overreaction to density, there was kind of overwhelming, and people say, density's not that big. We had engaged with a lot of the cloud players. Those are our target clients. And we are actually seeing deployments that are drawing 30 kW per rack. We are actually talking to cloud players who are struggling with, how do I go to photonic backplanes at 40 kW per rack? So they're out there and they're coming to a data center near you, and the infrastructure is just not really ready to support that level of density and that level of dynamic density. As we all know, the infrastructure, if we just look at the capital cost of the server and you look at the capital cost of data center, because the data center has not improved significantly and IT has, the data center is now the cost driver for the internet. And I mean that from a capital perspective, not services and labor. And if you look at kind of the underlying supporter of the data center and you think about where the grid is going, the grid is becoming less reliable. Now there's talk back to the elections of a major investment in the grid, but if you look at the reliability of the grid is ever increasing. An interesting stat, which I didn't know till kind of looking into this further, is U.S. has one of the most unreliable grids out there, right? Obviously places like India, Africa are there, but if you look at the modern European countries, much better reliability. And this is a significant issue for data centers for kind of two reasons. The adoption of renewables on the grid, which are uneven base loads, are continuing to make the grid less reliable. And if you look at the other issue that's coming down the pike that's going to be impacting data centers, is more dynamic compute. So we've all started data centers in a world where the power density, the power draw at the rack was relatively stable. Regardless of what the utilization at the server did, you'd plug in and it kind of stay stable. One of the things that Aligned Energy does is we're in the data center infrastructure monitoring business and server monitoring. We've got 12 million points in that business. We monitor thousands of servers, and what we see across the kind of cloud player servers is pretty significant power draw swings, and that's all a resultant of multi-threaded core and better efficiency. All the IT manufacturers are working to better match IT load with power draw. And so now we're talking about data centers in the future that the power draw of the data center is going to start to fluctuate significantly. UPS systems, chiller plants do not like fluctuating loads. And so you're talking about a convergence of a dynamic power, very, very large load, increased densification of those loads, 100 megawatt loads on an unstable grid that are dynamic, that itself is dynamic. So this is an area that the industry, and it's something that we at Aligned Energy are very focused on, needs to kind of chart a course of innovation of the next generation of data center infrastructure to support this, because it's just not being done in the industry. And if you look at the 2015, you see the bottom number on server power at idle, 47, half of what the previous power draw at idle is. And this is a trend that's continuing. Everybody in the IT industry is working on that. So this slide is not a function of the world without power, because all the data centers do it. How many of you have heard of this? Show of hands. This is one of the first 8K videos that is coming out on the internet. Everybody, I think, knows what 4K video, obviously 8K is double that. The guys in the video space that I talk to tell me that 8K is going to quickly become the standard and 4K is not going to really be that much around, just because it's here now and available, and so why invest that much in 4K? If you look at the difference of what's going to happen to the network, and again, sorry for the slide getting cut out, at the far end, 8K, 50 megabits per second. The average internet connection in the US is about 19, half the average connection speed of South Korea at 30. We're 17th in the world in interconnection speeds. And because we love video so much, my bet is that the U.S. is going to improve its stature and get there on the pace of video speeds. But it's a significant issue, and especially when you look at peering traffic. How important is peering for those? Peering is a function out there in the data center space that's becoming increasingly important to the CDN providers. And this is just a graph of one event in peering networks in a rather large metropolitan market, New York. And that was just a function of, this is a graph of megabits per second, medium download throughput. And essentially what you had, because, and I won't go into the specific providers involved in this, but essentially what you had is just a massive long period drop-off, all due to functions of peering relationships on the network. So the move and the pressure that's happening for caching a video at the edge are things that we talk about in these shows, but they're becoming very significant to large groups of users and are really going to drive the internet going forward and kind of the creation of edge infrastructure. If you look at just the size of 8K video and the need for caching, Netflix obviously, huge function and amount of the internet today. And if you talk about doubling the bandwidth of those providers, and if folks actually go to 8K video, video on the internet would be 10x what it is today, and it's already the driver. So these are things that we really need to get our heads around as we look at infrastructure. This is a shameless plug. I didn't put our name on it, but one of our data centers. One of the things that we're focused on in this space are these problems, which is how do we enable customers to be able to deploy racks at any density at any time? Because in the 25-year career that I've had in the data center business, what I found is it's very hard to predict what's going to happen in the future when it comes to loads. And I think other than the power issues and the fiber issues, one of the biggest issues that's happening in the data center space is just a function of the waste of utilization and the cost. If you look at delivery of infrastructure today, server utilization still is in that 20% range on average. Some of the cloud players higher, but they're also in some cases lower because they're provisioning super highways for kind of peak demand, and so utilization actually drops. And these are the tests that have been going on the cloud space. If you look at data center utilization, still around that 30%, by and large for the industry. Cloud players, much higher utilization, which I'll talk about in a second. But that means we're provisioning 17 data centers for every one needed at the other end from a megawatt perspective. If you look at the hockey stick and you believe in the growth of the video and the demand of data centers, that's a supply chain delivery model that is unsupportable in its current context. And that's something that us and other folks in the industry are focused on. How do we get rid of that 16 units of waste? If you look at it from a pure cost driver, and I'm clicking quick here to make up some time. If you look at just from a pure cost driver, just infrastructure, the middle line there is just the growth of the impact of cost of infrastructure. The bottom gray is servers, right? Again, relatively static over the years. Infrastructure growth as a function of the overall data center cost has been the driver. If you look at the industry today and you say we're a $200 billion industry, that's all of us in this room, hawking equipment and services and that, and you look at that current paradigm of 20% server utilization and 30% infrastructure utilization, what happens if the industry just goes to 85% infrastructure utilization like Google has successfully achieved and the other cloud players has achieved? You're talking about a drop in the industry that is significant, again, getting rid of that low utilization. You're talking about a $40 billion industry to support the same level of growth today. Now, the good news is we have that hockey stick coming in the Internet of Things. We have that hockey stick coming in video. But for those in the room are on the provider side or the infrastructure side, I truly do believe it's the end of the world as we know it. To kind of mirror what Bruce said, is there is just no way we can support the growth of the industry with the current level of low utilization of waste. It's just not, it's not feasible from a water, from a grid, from a power perspective. And that number of 40 billion, significant, and that's why you see what's happening in the server industry, the commoditization, all the factors from a data center perspective that we live with today are being driven by that economic. And we really live in a data center world today where it's kind of the have-nots, the with or without waste. If you look at the large data center hyperscale users, I like to think of data centers kind of in a unit cost of compute, which I'll explain a little bit why I like that metric. But that's the level of reduction of data center cost, and that's purely driven by utilization, right? So for those enterprises in the room, you got to ask yourself, can you compete in providing services to your clients with that much of a cost disadvantage in this digital world? Because that is literally the supply chain of what we all do and the information world that we live in. Can you live at that level of kind of disruptive disadvantage? And again, what's driving this is because data centers are statically built. We're living in a dynamic world of IT, and we're still building statically built data centers. Your average data center pod out there is, we all know this stuff, 10,000 square feet, 100 watts per square foot, gives you 2.5 kW per rack. And then what happens is when we go into a data center, we never hit the load that we're going to expect because we want to have that overhead and headroom. When we're high density, we go into a data center, we spread out our racks. It's not like a traditional pod can't take a 30 kW rack. It can. You just have to give it 10 times the aisle space. So once you spread it out and you lock in that waste, it's not like you're going to go back in time and then stick a rack in the middle of that aisle. On the metric, the industry, and I like to kind of chat with this maybe in one of the later panels, is kind of searching for that metric. The problem with traditional metrics that drive efficiency, they typically talk about the server output and the efficiency. The problem that we have in that space is the server output, it doubles every 1.5 years. So if you put in new servers and I have 1-year-old servers, you're 1.5 times better than me, and our data centers are the same. So I like the metric of just think of it in terms of a full unit of processing. In other words, a server running 100% full load. In theory, we would have this in a perfect world. You'd have 35 cents per cost of compute if you had 100% server utilization and 100% data center utilization. Obviously, you're not going to get to 100% server utilization. But I'd have you look down at the two low numbers there. The water number there at 1.8. 1.8 gallons is what you're using if you look at the fully embedded water of servers and of the data center. And this is reality today. A fully utilized unit of compute, which is essentially 5 servers, because you're running at 20%, so you have 5 servers to equal 1 fully utilized unit of compute, is 9 gallons, 9 gallons, right? So significant amount of water, especially when we look in the growth of data centers in these kind of hot, flat, crowded regions of the world. It's just completely unsupportable, which is why we're focusing heavily on what technologies can we bring to the space that dramatically reduce water. If you look at kind of the efficiency of enterprise players with things like PUE, it's getting better. It's getting more efficient. Their costs are going down, but they're still nowhere near the hyperscale level of infrastructure providers. And that's probably the central thing that I hope you guys take away from kind of the talk this morning is think about these, especially if you're an enterprise, think about these metrics or adopting some level, you're not going to get there overnight, but some metric that gives you a guidepost to use for continual improvement because it's critical. PUE to me is a metric that should be in the rear window. I think most people out there today are achieving hopefully good PUEs. They're actually not that dramatic when you look in terms of total cost. We're a big proponent of LUE, You know, you hear all the time people talking about a PUE of the data center, and then they go in and they use 30% or 20% of what they leased. You know, makes absolutely no sense. You shouldn't worry about your PUE at all. First, you should worry about your data center utilization, what you actually procure, lease, buy, and how you're going to use it. Much more important metric. We like kind of the combination of the two. If you look at a PUE of 1.15 against 1.5, 0 point is 1.5 PUE. You're talking about a 21% reduction in cost. That's good from a PUE perspective. But if you move up to 80% utilization, much, much more dramatic, again, improvement in cost. If you look at, you know, kind of the current state of the data center at that $3 per unit of compute, that's how much waste you could eliminate in a perfect world. And if you look at, let's go to the last one there, 40% server utilization, 85% infrastructure utilization, that's where the sophisticated hyperscale providers are going to. That gives them $2.35 per unit of compute cost advantage against the rest of the industry. So think about a world, which we are in now, but think about kind of an industrial world where our data centers are our factories producing the output. Would you be able to live in an industrialized world, pretend it just uses electricity and it's all manufacturing, where you had that much of a difference in your cost of utility? Because that's what the data center is today. It's a utility for compute, and you really need to focus on that utilization aspect. That's where, you know, if you drop it down to 15% server utilization on the other side, again, dramatic difference in the cost. So I like that metric. Be happy to talk for the data center wonks in the room if they like that metric too, and we get a cult following of adoption. But that to me are kind of the key takeaways on the industry today from a standpoint of, you know, it's really not going to be the bandwidth as we think about what's happening. The choke points are really the data centers. Interesting, the article the other day, a new fiber innovation, you know, talked about their ability to handle the entire internet on a single fiber. So we're not going to have technology barriers on the fiber bandwidth side. We're not going to have them on the server side, on the storage side. These guys and gals are all out there creating next generation technologies that are going to keep up. What it really is, it's incumbent on all this in the data center space and in the industry that are interacting with data centers is what we can do to kind of keep up with the Moore's Law level of innovation. And that's something at Aligned Energy that we're very focused on doing. And with that, any questions? Hope I made up a little bit of time. I'm not sure if I lost time or made up time.
You had a very good point about, you know, customers and leasing more capacity than they need. What in your research have you determined the reasons to be that they
There's two reasons. Yeah. Why are people leasing more than they need? I think one reason is a very good reason, which is you always want to have that capacity available when you need it. It's a perfectly legitimate business reason to do that. The other reason is, which is most of the waste. Let's give yourself 30% headroom for kind of, I want it there if I need it, obviously depending on your growth. But most of the waste or kind of over provisioning is just a function of, and you guys have all seen this, you get in a room, how dense are you going to be? And people just don't know. If you look at storage is dropping down significantly in density. Compute is going up. It is very, very hard to predict. So what we focused on and Aligned is how could we develop the underlying technology that would allow you to control capacity, which is kind of spinning reserve, having it there. Spinning to me is I plug into the Starline bus, shameless plug for Starline there, and I have that infrastructure immediately available. And that's what we focused on is how do we give folks the ability to control data center capacity that's immediately available at a lower cost. And for the higher density users, we're about 70% lower cost of spinning reserve, which is significant. We'll keep working on that number. But our goal has been to shift 70% of the cost to variable and connected to power draw. That answer the question? Yeah. Other questions? Okay. Or, sorry. I'm going to get in trouble if I answer that question, but I'll answer it anyway. So, and again, there's almost too much data on this for folks who like to probe into the internet. But if you look at the large cloud deployments, and I'll call them public, the issue that they have is they're trying to build a superhighway for peak. And therefore, you end up with a lot of times at low utilization, just like our highways are 5% utilized. But we have to have them because rush hour traffic sucks without them, right? So the average utilization of highways, the internet kind of follows that same path. You have to have peak. And so I don't actually believe there's going to be a lot of dramatic improvement on server utilization. I will tell you that more kind of ecosystem approaches to application, and what I mean by that is more like private cloud, where you're actually able to load shape to known loads. You can get into the 40, 50 server% utilization if you kind of have a predictable volume of load, and you're seeing that some folks are doing that with dramatic improvements. But when you get into, which is why I think that all things being equal, I don't think data centers are going anywhere, and I think that folks will always have a mix. All of the experts, I kind of agree with that. Kind of the bimodal IT or hybrid private clouds, because you can get much more efficient server utilization, infrastructure utilization in a more controlled subset of load. Did that safely answer the question? Yeah, the problem with the stranded capacity in the industry, because a lot of folks look at that and they say, oh, look, Colo industry is only 30% utilized. We have plenty of capacity there. But if you actually look at it as a function of leasing and K1s and all the public Colo companies, they're 90% leased out and utilized. So it's not like you're going to be able to go to stick a rack in the middle of somebody else's row. So unfortunately, that capacity is stranded unless somebody was going to go in and completely re-rack and stack in that. Most of that capacity is unfortunately stranded. And so the goal here, I think, for the industry is how do we build next generation data centers, which is what we're trying to bring to the market, which are kind of future-proof. In other words, densities go up, great, we can deal with them. If densities go down, we can spread out the infrastructure, because nobody knows what the next innovation is coming down the pike on the chip side. What typically happens on the chip side is you see these curves of you hit asymptotically and then it drops and it raises back up. And so given that unpredictability, to me, the importance is to embrace it, stop trying to predict it, and focus on infrastructure that doesn't care what shows up. And that's the unfortunate part about a lot of data centers today, is just the capacity is unfortunately stranded. Other questions?
Jake, you had a metric when you were talking about utilization and LUE. When I was working in the high-performance computing field, a lot of my clients were trying to come up with a better metric, and they were talking about a metric called flop to wall.
Yes.
Could you comment on why that's a good or not a good metric in terms of measuring utilization of compute?
I think it's a horrible metric because it doubles every 1.5 years. And so if you have a metric that doubles every 1.5 years by the law of more, I guess, you look pretty good every year. And so that's why I like the metric, which takes all the gravity metrics or the law metrics out of it, which is utilize unit of compute, which basically says whether servers double, triple, quadruple, you have a server, I have a server, let's see who drives them most efficiently. So it's a utilization metric of that, best available server. How are we utilizing it? Because we bought it, we're sticking in a data center, it's drawing power. So let's focus on what we do as participants in that, of the utilization side of the server, utilization side of the data center. So that's why I like that utilization, fully utilized unit of compute, because compute is just, it's a 63,000-fold increase. So that's why those metrics that include the performance of the server. Now, you should absolutely, the flop per watt is a fantastic metric to buy servers. And then once you've bought your server, you should flip over to, now I got it, how do I run it to the full capacity and the full, output? Answer? Okay.
But the CFO is making a decision for net new capacity, doesn't care about either of those metrics, right? They care about performance quality.
Yep.
The low lift of cloud, I think, is outpacing the heavy lift of anything.
Yep.
What's your thoughts on that?
Big believer in cloud and supporting it with better infrastructure. But I do believe if you just look at the cost, there's a point at scale, and it's really in the orchestration side of it. Most companies don't have the orchestration capability, the network orchestration capability to kind of keep up with the players. But the good news is there are a tremendous amount of providers in that space that are doing phenomenal things to bring on new technologies to the market. So if you look a little bit ahead and look to the more mass adoption of those, you find that, and these are studies that are well out there, above 300 nodes, above 400 nodes, you hit public cloud and you start to drop. 400 nodes is 5-6 racks, right? So it's really a function of the enterprise and where I think compute is going to go, and it's already going there, so it's not a difficult prediction, is this function of I scale up rapidly. There's going to be that multi-layered approach and orchestration of public cloud, private cloud, right? And you're going to see much more dynamic loads across the grid. I mean, we're looking at a world and preparing for it where you have dynamic pricing signals from the grid on negative energy, right? Because if you look at the world today with the adoption of wind and even nukes are running negative energy at peak times, right? So those are technologies that we're rapidly working on to kind of prepare for the, tighter collaboration between grid and data centers. I've probably taken up way too much time. So, okay. Thank you guys very much.